In the previous exercise, we took a deep dive into closures and looked at how to call them and create them. Now in this exercise, we'll see how closures relate to collections. Specifically, you'll learn how you can use closures to sort collections, filter collections, run calculations on items in collections, and much more. Let's dive in. One thing that's really common with arrays is wanting to sort your arrays. For example, let's say we have an array of last names. Obviously, this array isn't sorted, but if we wanted it to be sorted, we can just say names.sorted. And that sorts by the default comparison function. And so that's, in the case of strings, alphabetical order. So now A, B, C, Z, like we'd expect. All right, that's great, but it's not very customizable. Say we want to sort them in a different order. Say we want to put the Z's first and go in backwards alphabetical order. Well, we can do that with another version of sorted that takes a closure. So I'm going to select that and take a look at it. Now, we can read this, right? Because you learned how to write closures. So inside parentheses here, these are the types of the parameters that this closure takes. It takes two parameters, a string and a string, which are two items inside the array. And it returns a Boolean. And we have to return true if A comes before B and false if A does not come before B. Don't worry about throws. You'll learn about this later in this course. Now there's lots of different ways to write this closure depending on how verbose you want to be. I'm going to show you my preferred method, which is the middle ground that we were talking about in the previous exercise. I'm going to put the names of the two parameters here, which are A, B, and then I'm going to put in. And then I have to put this in curly braces, by the way, because that's how you make a closure. And now down here, I want to add my body. So I'm going to say A is greater than B. So if A is greater than B, that's going to return true, which means that A should be sorted first. Now let's look at this new array here, and you can see that it's now in backwards alphabetical order. Great. All right, let me show you another handy thing you can do with arrays and closures. Let's say we have an array of prices for items that we might be selling in a store. So we have $150, we have $10, we have $4.99, we have $2.30, and we have $8.19. Now let's say we want to filter this array and get an array with any prices that are greater than $5. I'm going to turn these off temporarily. We can make a loop to do that, but there's a built-in method on array that makes filtering arrays really easy. Let's try it out. We'll say let large prices equals prices.filter, and we'll select this. So what this is saying is it wants us to create a closure called isIncluded that's going to take a double, which is whatever values in the array here, and we have to return a Boolean, which is true if we want to include it in the new array or false if not. So I'm going to say price returning bool in, and we'll return price is greater than 5. Now if we look at large prices, we see it just contains 10 and 8.19 because those are the only elements in the array that are greater than 5. I want to show you another little shortcut you can do with closures here. Whenever you're calling a function that takes a closure, and the closure is the last parameter you pass to the function, you don't have to do this weird syntax where there's a parentheses and immediately a curly brace. Instead, you can just pass the curly brace immediately like this. And it just, to me, makes it look a little bit nicer, and you'll see people commonly write their Swift code that way. Okay, so we've covered filter, which again lets you take an array and filter out items that match a certain condition. There's another thing you can do. What if you want to do a little bit of work on every element inside the array, modify that somehow, and then get a new array with all of those modifications done? For example, what if we want to give a discount on all these prices by 90%? That's a perfect case for map. So we say sale prices equals prices.map. Let's take a look at this. So this closure takes a double, which is whatever element in the array, and you can return really anything you want. So I could convert all these to strings if I wanted, or I could convert them to labels or whatever I might want to do. In this case, there's still going to be doubles. To write this, I'll name the value here price, and it's going to return a double in. And it's going to say return price times 0.9. Now again, I could have shortened the syntax on this, but this is my personal preference. So if I look at this, I can see the prices have all been reduced by 90%. Another handy function is reduce. So the job of reduce is, say you want to run some kind of calculation, factoring in all of the elements of the array and returning some kind of result. Well, that's a perfect case for reduce. Let me show you how that works. So say we want to sum up all of the values in the array. Well, we can say sum equals prices.reduce. Now here you first give it an initial result. So what should the sum be when we begin? Well, 0, right? Because we're going to add something into it. And now you have to pass in a closure that takes in whatever the current result is, like it'll start out with 0, and then whatever the current value of the array is, so let's say 150 to begin with, and it's going to return the next result. So basically we want to say 0 plus the current value. And so, my preferred way of writing it here is we're going to say the result and the price, and it's going to return a double in, and we'll return result plus price. And we see here we've added them all up and we get 2698. And it's just a little bit of a shortened syntax for whenever you want to run some kind of calculation on everything in the array and get some kind of result. These functions that you learned right here can also be used with dictionaries. So let's take another example. Let's say we have a dictionary this time called stock. And the key is the price, and the value is the number of items we have at that price. Say we have 5 items that are $150. We have 2 items that are $10. We have 20 items that are $4.99. We have 5 items that are $2.30. And we have 30 items that are $8.19. So say we want to calculate the total price for all of these things. Which of these would be good for that? There's filter, which again, you give it a collection and you can get a new collection that's some subset of that collection according to some kind of filter. Then there's map, which is basically taking a collection and changing each value in that collection a certain way. And finally, there's reduce, which is looking through the collection to perform some kind of calculation and return a single result. Well, in this case, we're trying to perform a calculation to try to get a single result, which is the price, right? So that makes sense to do reduce. All right, now let's use reduce to calculate the total price of all the goods in our store. So we'll say let stock sum equals stock.reduce. And similarly to reduce for arrays, we have an initial result. We're going to set that to 0. And then we have a closure here. Now, this may look like a lot of text, right? But don't worry, we know how to read it. Let's just take it one little bit at a time. So first, next partial result, well, that's just the name of the closure that we're going to return the internal name, so we don't actually care about the name here. And then inside parentheses are the parameters that this closure takes. So first it takes the result, which is going to start out as 0, and then whatever we end up adding to that. And then we have a key value pair from the dictionary, and it returns a result. So the only difference between this and the array version is that instead of receiving a single item, we receive a key value pair. So we're going to write something similar to before. So we'll say result, and this time pair, and it's going to return a double in. And now what we're going to do here is we're going to say return result plus, and this time we have to do a little bit of a calculation. We're going to say pair.key times pair.value. In other words, the key is the price, so 150 times the value, like 5. So 150 times 5, but of course this is an int, so we need to cast it to a double. So I'll just surround that in parentheses there. And there we go. The total value of the stock in our entire store is $384.50. Not bad for just a couple lines of code.